Hello, so isomers, as I said in the previous video, are arrangements of a molecule, the different arrangements which have the same number and types of atoms. Same number of atoms, same types of atoms. So they basically with the same number and types of atoms, okay? So, for example, with methane, clearly there's only one arrangement of this can exist, carbon with 4 hydrogens around it, which actually, I should point out, in it's in a tetrahedral arrangement, so the three-dimensional, that's coming out, that's going away from us, and those two go out along the page, so it's actually a three-dimensional arrangement in space, okay? But there's only one arrangement, okay? So there's one, okay? With ethane, so that's methane, okay, with ethane you got okay, so again, if you draw it sort of like that and like that, it's again, that's the same as that, it's just on its side. So with ethane, there's only one isomer that can exist, okay? So it's 1 times isomer, okay? With propane, do you want to quickly have a go and see if you can answer that? So if you draw it like that, remember to put the hydrogens in, how many arrangements of this can you get? I'll draw it up now for you. So the answer to propane is, you get that one, and then you could try doing that, okay? You must always put the hydrogens in. So, but again, that is actually this one that's a continuous chain. Dried out a bit. That's a continuous chain, okay? And this is also a continuous chain, okay? So that is actually the same as that, okay? So there isn't any other arrangement you can, but if you put it up there, again, it's just the same as this, flipped over. So there's only 1 times isomer, okay? That's propane. If you go to butane, okay, so you got 1, 2, 3, 4, 5, or 4, okay, sorry. Start again. 1, 2, 3, 4, okay? And again, these are hydrogens. Normally when I do it, actually, I don't put the hydrogens in. I lay out all the carbon chains first to see how many arrangements there are, and then I fill the hydrogens in afterwards. So I'll leave it like that for the moment. So you get 4, or you can have 1, 2, 3, and then you can have 1 there. Okay? So yeah, if you have 4 in a row, or you can have 3 in a row and 1 coming off. So that's basically 3 and 1 coming off, or you can have 3 which are bent at the right angle and 1 coming off, but that's the same thing. So if you try that option as well, okay, that's actually the same as that, just flipped over, okay, along that axis there, okay. So that's the same as that, so that doesn't count. So there isn't any other arrangement. If you have 1, 2, and then you have say 1, 2 like that, okay? That is actually just a continuous chain like this, okay? So you got like that. Pen dried up a bit overnight. So yeah, that's again the same as that, so that doesn't count either, okay? So okay, so the number of isomers of butane is actually 2, okay? There aren't any others really. You could try that, okay? And then you could try, I suppose, that and that. That's just that, again, flipped over through that axis there. So that's the same as that, so that doesn't count either. Or you could try 1, 2, have I done that way? But that's again 3 in a row with one coming off the central, which is the same as that, 3 in a row with one coming off the central. So that doesn't count either, okay? Because that's the same as that one. Okay? 3 in a row with one coming off, the middle one. So there's 2 isomers of butane. Can you now try pentane? So if you can work this out one out, and then I'll write it out. So you got 1, 2, 3, 4, 5, okay? How many do you think there are of this? Now I turn the video on again, unpause it and I'll write them out. So you got 5, the other option is 1, 2, 3, 4. I normally do, what I do is I write all 5 out and then I do 4 in the chain and then 3 and then 2 and I put on side chains. So you get 5, you could have 1 here, okay? So that's 1 coming off the second one, or you can have 1, 2, 3, 4, have 1 coming off there. But that doesn't count because if you flip it through that axis, it's just that one. That's wrong, okay? That's not new, that's the same as that if you flip it over. Like that, basically, okay? So another option is having 3 in a row, 1 there and 1 there, okay? So again, that's C5H12, okay? 3, 6, 7, 8, 9, 10, 11, 12. 3, 6, 9, 12, that's C5H12, okay? You must always check these formulas should always be the same with isomers. So that's another option. You could also write 1, 2, 3, 4, okay? But again, that's that one flipped through that axis there. So that's the same as that, so that's actually not new, okay? So the total number of isomers here is 1, 2, 3, okay? And then we must put the hydrogen in, of course, as well. Okay, I didn't need to do that one actually, it's these ones I need to do. So you got you must put hydrogens in. You must always put all the hydrogens in. I think the exam allows you to miss 1, 2 hydrogens out, but you basically got to put 95% of them in. It's best just to do them all. Okay? And okay, so there's 1, 2, 3 isomers of pentane. Okay? Next is hexane, okay? So if you can try hexane on your own. So you got 1, 2, 3, 4, 5, 6. How many isomers does this exist? Okay. If you want to unpause now, I'll show you how many things exist. How many exist. So you got 6 in a row. 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5, 2. Okay. 1, 2, 3, 4, 4, 5, 6. 3, 6, 9, 12, 13, 14. Okay. That's the same as that one. See, 6, 3, 6, 9, 8, 14, okay? Another option is 1, 2, 3, 4, 5, 6. Another option is 1, 2, 3, 4, 5, 6, okay? Another option is like that. But that's actually that flipped through that axis there. So that's the same as that, so that's wrong, okay? Another option is 1, 2, 3, 4, 5, 6, okay? Is that new? Well, that's got 4 in a row and 2 coming off number 2. That's got 4 in a row and 2 coming off number 2, so that's actually the same as that one. So that's wrong, okay? So I think with hexane there's 1, 2, 3, 4, 5, 6, 4, 5, 4, 4, 4. I think it's 6 with hexane. 1, 2, 3, 4, 5, 6. Remember, we need to put the hydrogens and all this as well. I mentioned in a previous, earlier in the video, about hexane, and I recently said there were 6 isomers. There's actually 5. For Nat 5, it's 5, okay? 1, 2, 3, 4, 5, okay? The reason why this and this is different is, I wrote down this is a 6th one, and these 2 are wrong. At advanced high level, you get taught these are actually different isomers, because that's when they're both on the same side. This is called cis. When the groups are on opposite sides, it's called trans isomer. But for Nat 5, you can forget that. It's just 1, 2, 3, 4, 5. For Nat 5, these 2 are the same. Okay. So, yeah, just forget what I said about cis and trans, because that's not relevant in Nat 5. Yeah, this is isomer theory is a bit more simple at Nat 5 level. Anyway, there's 5 isomers to 5 isomers to hexane, okay? When you're teaching, it is teachers do get a bit when you're working with Nat 5 higher and advanced higher, you do get a bit muddled sometimes, and you have to check the syllabuses to see what's actually being taught. So sometimes you're working with the high grade and you start bringing Nat 5 knowledge. Sometimes you're in Nat 5 and you start bringing high grade knowledge, and you have to sometimes remind yourself stuff is advanced higher as well. So. Anyway, cheers. Please subscribe. Help me get to 1,000. So, to work out 9 isomers, I will demonstrate to you. Rather than just writing them all down, I'm going to show you the actual method to go about searching, because it's trial and error basically. You're going to try different structures. A lot of students struggle with this. Teachers also struggle. Professors struggle. People with PhDs struggle. Anyway, so 9 isomers. So heptane is 1, 2, 3, 4, 5, 6, 7. Okay. And there's 9 isomers. Next one is next option 1, 2, 3, 4, 5, 6, 7. Okay. Then 1, 2, 3, 4, 5, 6, 7. Okay? So those are 3. Next is 1, 2, 3, 4, 5, 6, 7. Okay? Now that's actually the same as that one. If you flip that through the mirror axis, flip it over through that mirror, so you get the reflection. It's like flipping a pen over. So that's not one. Okay. So that's 6 in a row. So it seems to be we run out of options of 6. So we'll try doing 5. So you get 2 third position. 4th is actually third. So we'll go to 5 carbons in a row. 1, 2, 3, 4, 5. 6, 7. That's 1. 1, 2, 3, 4, 5. 6, 7. That's 2. 1, 2, 3, 4, 5. 1, 2. Okay, so positions 2 and 3, and then positions 2 and 4, and then 2 in position 3. That's 1, 2, 3, 4, 5, 6. 3 to go. Could try. So that's 5. Go down to 4. 1, 2, 3, 4. 1, 1, 4, 5, 6, 7. Okay, that's 1. That's different from these. 1, 2, 3, 4. 6, 7. That's actually the same as that if you flip it through that mirror, that sort of axis. So that's not 1, okay? That's the same as that. If you flip it that way and then flip it over, flip it that way and then roll it. Then we could try, that's 4 in a row. 1, 2, 3, 4. 5, 6, 7. That's actually got that length, which is 5 in a row though, and 1 in position 2 and 3. So that's actually the same as that one. It's 5 in a row, 1 in position 2 and 3. So that's the same as that. So that's not 1. Okay. Next option. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. That's different from that, and that's different from that one. Okay. 1, 2, 3, 4. 1, 2, 3. Okay. That's actually the same as that one if you flip it through that axis. So those are actually the same. Okay, so we'll cross that one out. So 2 in that one, 1 in that one, 2, 1, 1, 1, 1. That's 2 options with 4. You got 1, 2, 3, 4, 5. Okay, that's actually a chain of 6 with one number 3. Which is the same as that one. Okay? So that's actually the same as that, so that's not 1. Okay? So we got 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay? That's 1, 2, 3, 4, 5, 6, 7, 8. Ninth one. 1, 2, 3, 4, 5, 6, 7. That's 5 in a row. I don't think it actually got that. So 5 in a row here was 5 in a row with 1, 2, 1, 3. 5 in a row with 1, 2, 1, 4. 5 in a row with 2 and number 3. 5 in a row. This is 1 either side number 3. So this is different from that. So that's the 9th. Okay? So that's demonstration of how you can find isomers. it takes a lot of work, it's hard work, it's not easy, but if you just go through lots of different options like that, and I've crossed out the ones which don't work, okay? So that's wrong, that's wrong, that's wrong, that's wrong, and that's wrong. Leaving 1, 2, 3, 4, 5, 6, 7, 8, 9 that are correct, okay? So you could try octane, which has got 18 isomers next if you want. That's tough. try octane. In another video I write them all out.